This is the modern periodic table. There are 118 elements arranged in the periodic table in a very systematic manner. There are some properties related to these elements which define the way in which these elements react. Since the elements are arranged in a very well organized manner, even these properties follow some particular trends. Let's see how. One such important property related to the elements is their electronegativity. Electronegativity is the tendency to attract the shared pair of electrons. When atoms combine, so at times we know that carbon atom has 4 valence electrons. To complete its octet, it shares electrons. So 2 oxygen atoms combine with the carbon atom, so they form a CO2 molecule. So now both of them share 2 electrons each. So now carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and each oxygen atom also has 8 electrons. But now the problem is one of them wants to pull the electrons, the shared pair of electrons, towards itself. Who do you think will win? Will it be oxygen who can pull the shared pair of electrons, or will it be carbon who can pull the shared pair of electrons? Let's try to answer this. In a periodic table, we know as we move from left to right in a period, the atomic size decreases. When we move from top to bottom in a group, the atomic size increases. So across a period, the atomic size decreases. As the atomic size is decreasing, the outermost shell is pulled closer to the nucleus. This leads to increased attraction of the electrons towards this nucleus, and hence the electronegativity, the tendency to attract the shared pair of electrons, increases as we move from left to right in a period. Again, let's revisit how this happens in a period. From moving from left to right in a period, the atomic number increases. This leads to increased nuclear charge, as nuclear charge depends on the charge of protons. So as the number of protons increase, the nuclear charge also increases on moving from left to right in a period. The increased nuclear charge leads to greater pull on the outermost shell, and so the outermost shell is pulled towards the nucleus. This leads to atomic size decrease. As the atomic size decreases, the tendency to attract the shared pair of electrons increase. Because the outermost shell is closer to the nucleus, it can now attract the shared pair of electrons more towards itself, and so the tendency to attract the electrons increase, which leads to increase in electronegativity on moving from left to right in a period. We have 3 elements: sodium, magnesium, and aluminium. Which is the element which has the least electronegativity? Let's try to locate these elements in the periodic table. We have sodium, magnesium, and aluminium. So we just studied that when we move from left to right in a period, the electronegativity increases because the outermost shell is closer to the nucleus. The tendency to attract the shared pair of electrons increase, so the electronegativity increases. And so out of sodium, magnesium, and aluminium, the one with least electronegativity is sodium. Because when we move from left to right, electronegativity increases. So when we move from top to bottom in a group, so we know on moving from top to bottom in a group, the atomic size increases. This leads to increased distance between the outermost shell and the nucleus. This increased distance leads to lesser attraction of electrons towards the nucleus, as now the nucleus exerts lesser force on the outermost shell. Therefore, the tendency to attract the electrons decrease, and the electronegativity decreases when we move from top to bottom in a group. So let's revisit this, what happens in a group. So when we move from top to bottom, the nuclear charge increases. Also, in a group, we know as we move from top to bottom, the number of shells increase successively. The effect of the increased nuclear charge is that it tends to pull the electrons close, but the increased number of shells overweigh the effect of increased nuclear charge. So in effect, the atomic size increases because of the increased number of shells. Since the atomic size increases, the tendency to attract the shared pair of electron decreases, because now the outermost shell is quite far away from the nucleus. The nucleus does not exert a greater force on the outermost electrons, so the tendency to attract the electrons decrease, and in turn the electronegativity on moving from top to bottom in a group decreases. Let's come back to our question. So, is it carbon which can attract the shared pair of electrons towards itself, or is it oxygen that can pull the electrons? So let's locate carbon and oxygen in the periodic table. Here is carbon, here is oxygen. We know that in a period, when we move from left to right in a period, the electronegativity increases. As the electronegativity increases, so the electronegativity of oxygen is greater than carbon, as oxygen lies towards right in the periodic table, and so oxygen is able to attract or pull these electrons more towards itself. So both these oxygen atoms pull the electrons more towards themselves, and so oxygen is more electronegative than carbon. So in a periodic table, as we move from left to right in a period, the atomic size decrease. This decrease in atomic size leads to a greater tendency to attract the shared pair of electrons. Hence, the electronegativity increases. When we move from top to bottom in a group, the atomic size increases due to the increased number of shells. This leads to lesser attraction of the electrons, and this lesser tendency to attract the electrons leads to the decrease in the electronegativity when we move from top to bottom in a group.